Okay, so we're gonna write down the definition of dilation. So, Juan, you said it gets what or what?
Bigger.
It's gonna get bigger or smaller. We're gonna use some better terms. So this is to enlarge or reduce. Okay, so the enlarging would obviously be the one that's getting what? Bigger. Reducing is the one that's going to get smaller. So this is to enlarge or reduce something proportionally. And that is the key word here. Have you guys heard that word before? Proportional?
Yes.
That is like the key word here. So think about like if your body type is proportional, that means like your arms kind of match the length of your legs and your torso. You're not like super awkward lengths everywhere. You're kind of all proportional. Yes, you need to write this down. So that is what keeps it the same shape. Keeps the same shape. So we said it's not rigid motion. So it is changing this. Sorry, it is keeping the same shape, but what is it changing?
Itself.
Good, but different size. So the only thing changing with the dilation is the size. Okay, so we put in some of these real world examples. I'm going to draw one that's more geometrical. If you can draw this one in. So let's say we have a rectangular side table. And it's going to be 5 by 8. Let's say we want to scale it up. We're going to be using that word a lot, scale. Let's say we want to scale up the dimensions to like a bigger table that's still the same shape. We still want that rectangular shape. And we want it proportional to this table, but a different size. So let's say we want to scale it up. We want to double the size of it. So my scale factor is going to be 2. And we'll do lots of examples of these today. So all we have to do here to dilate up is going to double each of my sides here. So what is 5 times 2? 10. And then what if I double the other side? 16. So that is what it means to be proportional here. Basically, like, are they factors of each other? Okay, and we'll talk a lot about scale factors, but that would be a scale factor of 2. And scale factor is represented by the letter K, which we'll talk about in a second. So, so what do we mean when we say that the dilation was an enlargement? We know it's getting what if it's enlarging? It's getting bigger. In terms of a scale factor, this means that I have a scale factor greater than 1. And we're going to just write in some of these vocab words. So the scale factor is just by how much it's increasing or by how much it's decreasing. So if it's greater than 1, we know it's going to be an enlargement. So this is to increase proportionally. To increase proportionally, and that scale factor has to be greater than 2. Okay, make sure you're writing down these definitions. Okay, so what do we think the definition for reduction would be? To decrease proportionally. Can you read my handwriting now? Is it okay?
Yeah.
Okay, so this is going to be a scale factor. We're going to do one of those compound inequalities. It is going to be less than 1, but still greater than 0. So, like any sort of decimal or fraction, we're not going to go into the negatives for reduction, but it has to be less than 1. Okay, and then the last thing here is the scale factor. What letter did I say represents scale factor?
K.
K. So you'll always see it written like K. Okay, and again, it's just like the number by which we're increasing or decreasing, but an actual definition is the ratio of corresponding lengths. Do you guys remember that word corresponding? We've heard that lots by now.
Okay.
Just means the matching sides, basically. The ratio of the corresponding lengths of the image to the pre-image. You guys remember those words? When we talked about transformations?
Yeah.
Which one is the original? The image or the pre-image?
Great.
The pre-image. Okay, so you will see scale factors written as a ratio. So it's always the image over the pre-image. The image over the pre-image. That's how we got our scale factor of 2. So 16 over 8 would give me a ratio or the number 2. It can also be written in this format. So, or sometimes you'll see it with a colon. And we'll see examples of that. But again, like, don't overthink what scale factor means. It's just if it's greater than 1, it means we're getting bigger. And that's telling me, are we doubling it? Are we tripling it? Are we quadrupling it? And then vice versa with reductions, it's going to be that fraction that's getting smaller by half or by thirds. Okay, so we're going to try some examples. These are really easy. So we're just determining whether it's a reduction or enlargement. Some are based off of pictures, some are based off of scale factors. So it tells me my scale factor here is 5 to 2. I can also write that as a fraction, 5 over 2. So what we're trying to determine, is this greater than 1 or less than 1? This is greater than 1, right? Because I know 5 divided by 2 in decimal form is what?
3.
5
2.5.
divided by 2 is 2.5. So that is definitely greater than 1. So if it's greater than 1, is it a reduction or enlargement? Enlargement. So we're really just worrying, is it less or greater than 1? Okay, our next one. We want to see, has it gotten bigger or smaller here? How do I know which one is my pre-image? Somebody give me a clue. Elijah?
It has those columns.
The image would have do you remember the name of the prime symbols? So the ones without are actually the pre-image. So that is the original. So did it get smaller or did it get bigger?
Smaller.
It got smaller, so this is the reduction. Okay, the next one, we're going to be seeing lots of this code today, so I'm going to write out what everything means. The D is for dilation. So it is a dilation from our starting point or the point of dilation. So that's just our starting point, where we're dilating from. And then the only number here, what do you think that number represents?
5.
Yes, it is 5, but what?
Scale factor.
The scale factor. But I'm glad that you saw that it was 5. I can't laugh right now. Okay. So that's our scale factor, and then that is like the point that we are dilating. Do I need to pause? Okay, so the only part that we're concerned about here is the scale factor. So is my scale factor greater or less than 1 here? It is greater than 1, so what would this be? Enlargement. But we'll work with that code in a second, so you do have to know how to read that. Okay, and then today we're dilating lines, so here's an example of a dilation of a line. How do I know which one is my original, and how do I know which one is my image? Good, the prime symbol. So my original would be from O is my starting point to A. So that is my line, OA. That's my line segment. That's my original, or my pre-image. To get from O to A prime, did that get longer or did it get shorter? It got longer, so it was enlarged. So we're only dilating lines today. We're not going to be worrying about figures. Okay, so I'm going to pause the video here so you can try these last two with your partner. You want to pick out the scale factor, and try. Okay, so if you compare 2/3 to 5/2, make sure you notice that just because it's a fraction doesn't necessarily make it a reduction. We kind of think it's fractions as smaller, but if the numerator is bigger, then it's going to be greater than 1 or an enlargement. So make sure you're not always just assuming that it is a reduction. Oh, okay. This is from Mr. Bird. He made this. So, do you care about these little things? You want to take a guess?
No.
What washes up on small beaches?
Dolphins.
What?
Microwave.
Okay.
I
get
They're bad. I thought they were like 20 pounds.
Yes, it's recording. That's okay. Okay, this part is not meant to be confusing, but you just gotta bear with me for like the first few. You'll get the hang of it, but you do have to understand how to read these codes. If you have a colored pencil, did everyone grab a colored pencil when they walked in? You don't need one, you don't need one. But if you would like one, it kind of helps. Okay, so looking at our little code over here, the D stood for what? Dilation. So do not confuse that with point D up here. That is just dilation. So this is my starting point. Okay, so it's the dilation from point what? Point T. So that is our starting point. So I'm just gonna like highlight that. It does get, I can erase mine. So you don't want to just like mark up your whole entire line here because you're gonna have to be doing all of these without erasing. So I can erase mine. That's mine drawing all over it. Okay, so this number 3 is what? That is my what?
3. Scale factor.
That is my scale factor. So it's kind of get used to getting your scale factor. So my K is equal to 3. I didn't say this on the definition of scale factor, but all that you have to do to dilate is multiply your pre-image by the scale factor. So whatever we're doing here, we're just tripling that. So we want to find our original length of this line segment. So it's from T to what point? What's the other point they gave me? Y. So that's telling me like this is my original segment right there. How many units is that? It's just 1. So I'm going to do my pre-image times my scale factor to get my image. Okay, and we won't write this every time, but just so you have it to refer to. So my pre-image length is just 1 unit. I'm going to multiply that times my scale factor of 3. So 1 times 3 gives me 3. So we just tripled in size here. So I'm going to go back to my starting point, and I'm now going to work in the same direction as it had me going, but I'm now going to count 1, 2, 3. And where did that take me? Oh, did I start the wrong line? I did start the wrong line. I went the wrong direction. So we're starting at T, and we're now counting to the right. Sorry. So 1, 2, 3. What point? T. So it'll kind of have you already going in a direction. You just want to go with that direction. Okay, so let's try the next one. What's my scale factor here? 1/2. Is that a reduction or an enlargement? That's a reduction. So we'll be taking half the length of my original. Where's my starting point here?
R.
R. R. And where do I need to count to? F. So 1, 2, 3, 4, 5, 6 units long.
So it'll be 3.
So I multiply my scale factor by my pre-image length. So when I multiply by 1/2, that's the same as dividing by what?
2.
2. So what is half of 6? 3. Okay, it doesn't matter in this case which direction we go, but always go back to your starting point, and I'm now just going to count 1, 2, 3. So what point is that? W. So these are a little weird, but it's just trying to get you used to the format. Okay, we're going to save these last 2 for last because we have to work backwards there, so it's a little different. I want you to try this one with your partner, please. So I'll pause the video here and try letter D. Okay, so you should have gotten T here. you need to find your original length. So I start at H, and I count to K. So I have 1, 2 spots. So there's my pre-image. I multiply it by the what? Scale factor. So 2 times 3 gives me 6. You go back to your start, and I count now 6 spots. So 1, 2, 3, 4, 5, 6, and that will take you to T. I think, don't get confused. Some people like start at K or things like that. You always want to start back at your point of dilation. Okay, if you look at E, what's different about E?
Negative.
It's a negative number. So, do we think this is a reduction though?
No.
Why is it not a reduction?
Because it's not a decimal.
Right, so I know that reductions are only in that range from 0 to 1, so anything outside of that is still going to be an enlargement. This just tells you to move in a different direction or the opposite direction than what we were already moving. So we do the same exact process. So where's my starting point here? T. Where do I need to count to? M. So I went 2 to the left there. So I do the same thing. I take my scale factor. I take my pre-image. I multiply it by the scale factor. So 2 times negative 2 is negative 4. But if it were a positive 4, I would go right back here and count to the left because that's the way I was already moving. Because it's negative, it tells you to move in the opposite direction, so it's almost like a reflection. So we're going to move to the right, 1, 2, 3, 4, and that takes me where?
Okay.
So it's almost, and once we start doing triangles, you'll see that it just like reflects also, yeah.
Say a large number is either greater than 1 or less than negative.
I guess so. Yeah.
I think it's positive.
It's not positive.
Man, you're working from here to here. That's correct.
They gave me the image, so we're gonna have to like work backwards to find where we started or what my original length was.
What?
So the way I think about it is I just like divide because here I'm multiplying by the scale factor. Now you're gonna be dividing by the scale factor. Divide by K. But I'll also show you another way we can think through it. Just give me 1 second to answer your question. Okay, so we do the same thing, but we're now finding like our image length. So, my starting point is where here? P. And I need to count all the way to R. So I'm going to go 1, 2, 3, 4. That length of 4 is like my image. So we're trying to go backwards to find my pre-image. Okay, so I know my scale factor is 4. I know that my original length is 4. So I'm going to divide my original length by the scale factor. So 4 divided by 4 is 1. That is 1. So I'm going to go right back to my starting point and I'm going to go 1 spot and that will give me my pre-image. So what is it? W. That's one way to think about it. I also know like the scale, usually I would do the scale factor. So 4 times my pre-image would give me 4 as my length. So you're thinking like 4 times what gets me to 4? 4 times 1. So that's another way that we can do it, and I'll do it that way on the next one down here. So these make your brain hurt a little bit more just because we're having to work backwards. Okay, so what's my starting point for the last one? F. Where do I need to count to? Okay, which is what? 1 spot. So I know my scale factor is 1/8. That is an enlargement or a reduction? Reduction. So I'm going to set it up like I did here. So my 1/8 times my pre-image is equal to my image, which I know is, what did we just say? Is 1. So what times 1/8 would get me to 1? 8. Okay, so that means I'm going to have to count from F 8 times. So 1, 2, 3, 4, 5, 6, 7, 8 would take me all the way back to D. So those are, you are dividing still here, but fractions are a little tricky. Okay, I'm gonna pause for questions. Okay, so the dilation centered at 0 has a scale factor of what? 3. I get used to writing K. You'll just see that a lot. So K equals 3, and it gave you like all of these original values or the pre-image values. So if you look, like this is a line AB, and it is 8 centimeters long. The first one here is asking me for A prime, B prime, so that's my image. So if I know my scale factor is 3, all we have to do is take my original length and multiply it by my scale factor. So 8 times 3 would be 24. So now you're getting to see kind of like the easy side, or like how easy dilations can be. You just multiply everything by that scale factor. So I'm going to write that over here. That's 24 centimeters. So we have scaled it up, or tripled in size. Okay, O to B prime. So I need my original length, OB, which was what? 7. So to find OB prime, what do I do? Multiply it by 3. So 7 times 3, 21 centimeters. And I'm going to fill that in my picture because you'll need that in a second. So we're literally just tripling the size of everything. So my last one, OA is 6. So how would I find OA prime?
6 times 3.
6 times 3 give me? 18 centimeters. Okay, look at the next one, A to A prime. A to A prime. Do we know that?
Yes.
Well, we don't know it, but we can figure it out how. Go ahead.
Fine. 18 minus 6.
Good, we have the whole segment and this little piece, so we're just going to subtract 18 minus 6 to get 12 centimeters. Okay, so go ahead and fill in B to B prime. Fill in B to B prime. What are we subtracting there? 21 minus 7, so I get 14 centimeters. Okay, the last question is asking for a ratio of OA to A prime. So what is my length of OA? 6. And I'm going to put mine in this format with the colon. And then A prime was 12. If this were in the other format, like a fraction, what do I always have to do with fractions?
Divide.
Simplify or reduce them. So what would that reduce to? 1/2. So you can, either way is fine. You can do 1 to 2, or you can leave it as a fraction 1/2. Most of the time, scale factors will be written as a fraction, but you do need to know both formats. Okay, I'll pause for questions, and then you can try the next one on your own, and it is a, well, you tell me, what's the scale factor of the next one? 1/2, so what is it?
Dividing.
Yeah, we're dividing, or it's a reduction. Okay, so these are your answers for a scale factor of 1/2. You just took half of everything. And then what did we find as our ratio of OA prime to A prime?
1/1.
A prime. Yeah, so 3 to 3 we would simplify to 1 to 1. Okay, so this is not a scale factor here. This is just asking you for the ratio between these two segments.
This is really confusing.
What I want you to take away from this page, I am recording. What I want you to take away from this page is that we always multiply by the scale factor. Okay, when we multiply by 1/2, we are really just dividing by 2, but you always multiply by the scale factor. So you'll see that once we start working with triangles, like you take every side and you triple them. We're multiplying by 3. Or if it's a scale factor of 1/3, we would divide it by 3. So you're just doing that same pattern to everything. So it's not difficult. I know that the way this format is, it looks kind of tricky, but the whole concept of dilation is just to use that same scale factor over and over and over again. So we're going to look at the difference, and then I'll let you get started on your homework. And this will not take very long, but you need your ruler now. Oh, here's the next one. Did you hear about the Italian chef that died?
This seems so easy.
Oh my god.
feel like it'd be-
That's not even fun. He passed away.
Fluffy thinks it's fun.
Oh, man. You got jokes. The only reason it was funny was because of
Okay,
Wait, were those your jokes?
no, Mr. Bird made this slide,
Okay, I was about to feel bad.
so I guess he adds jokes in his all the time. So he's just more fun.
Yeah,
Oh.
that's true.
Why don't you add jokes? Are you recording?
Yep.
Oh. Hello, YouTube. You're gonna have to edit a lot.
Nah, I don't know how to do any of that, so it's all good.
Oh, Lord.
I'm gonna watch.
All the
Okay. So, this part is really easy. We're just gonna do 4 dilations here. We're noticing the difference between when the point that we're dilating from is on the line versus off the line. And you've probably already seen that pattern, but it's just kind of reinforcing it. So I've done this every class period and always done the wrong side. So that is my pre-image, so I'm gonna work on the image side. What does it give me as my scale factor on your paper? Looking at this, we're dilating from point O with a scale factor of 2. So it should double in size here. So what you want to notice is the point O is on the line that I'm dilating from. So it should not leave the line. These are kind of weird to see, but I just count the lines in between. So I went up 2 to get to A. So that length is 2. What do I do with that originally? You double it, multiply it by 2. So I should be going where? 4. So it should double in length. So 1, 2, 3. Oh, these are stressful. 1, 2, 3, 4.
Yes.
Yeah. So there's A prime. So we're just doubling. What's the length of OB? You're gonna say 5? So if that original length is 5, what do I need to do with that? Double it to 10. So I need to count 5 more. 1, 2, 3, 4, 5. So that is B prime. So the only thing we really want to notice here is it's getting farther away from that point of origin, or that point of dilation, but it's still staying where? When we're dilating a line from the line, it's going to just stay on the line. Stays on the line. Okay, the next one, or was that an enlargement or a reduction? That was enlargement. This next one is a what? Reduction. My scale factor is 1/2, so it should be splitting the length in half now. So we're going to count, we have 2 as my original length. So what is half of 2? 1. So it should be here in the middle. There's A prime, don't forget your prime symbol. And this is a great time to use your colored pencil. So it stands out a little bit more. And then the length of OB, I'll give you a second. I think if you just count the lines in the middle, it should work.
7.
It's just 6. 1, 2, 3, 4, 5, 6. So what do we do with that original value? Divided by 2 to get 3, so it should be 1, 2, 3. B prime should be in the middle. So we're still on the line, correct? But we got closer to that point O. So that should be half the size. Okay, so at the bottom, we're just going to summarize that, maybe. So what do we notice when we dilate a line with the center of dilation on that line? What do we notice?
Stay on the line.
It stays on the line. I'm going to say the points stay on the line. Do you guys remember the word for points on the same line? Collinear. It's just a matter if it's enlarging, it's going to move farther away from that original point, or closer if it's a reduction. But you just want to notice it'll always stay on that line if that's where we're starting from. Okay, flip to the back. This is where you will need your ruler. Okay, so on the image side, we see that this is when the center of dilation is off of the line. So if I look at my pre-image, my point O, where I'm starting from, is off of that line. So we're going to see the difference here. The goal is we don't want it, or it won't stay on the line like our other one. So my scale factor that they gave us was 3. So it should be tripling in size. But you'll need your ruler for this. So with your ruler, if you can connect point O and A and kind of extend that out as far as you can. So with your ruler, you want to mimic these red lines. You're going to draw. With your ruler, connect O and A and extend it out. Do the same thing with O and B. You can use your colored pencils here. And you want to make it as accurately as you can. You didn't get a ruler? They're right here. Everyone else has a ruler?
Can you just copy it?
You're going to draw the red lines right now. So you just want to draw the red lines right now. Everyone has extended those out. Okay, that's showing you kind of like the trajectory of where your dilation will end up. So we always want to find our original length here. So let's measure from O to A. On the centimeter side of your ruler, if you can measure how many centimeters long OA is. Are we getting the same answers? 2. I've heard 2 on that side. I've heard 2 on this side.
How do you get 2?
On the centimeter side.
Oh. Oh, I thought that was you just. Never mind.
So we have 2 centimeters here. What about OB?
2.
Should be the same. Okay, what's my scale factor that we're multiplying by?
3.
3. So 2 times 3 will give me
6.
a length of 6. So starting from O, we want to measure where 6 centimeters is, and that's where you'll put your A prime and B prime.
That's what blue line.
That's where the blue line comes in. So you want to measure back from the O, 6 centimeters to mark where your new A prime is going to be. So you want to get it as accurately as you can so that they line up. So measure 6 centimeters. Two times 3.
What is it?
Hey, miss, stop recording.
Oh no, I didn't. Forgot.
I video.
On the centimeters.
Dude, this recording is terrible.
You have to redo it.
Okay, so from that point, so you should have measured a point up here and labeled that A prime. You should have measured 6 centimeters here, mark that as B prime, and then you can go ahead and connect A prime to B prime to create your new line.
I already did it.
So what do we notice, or what type of lines did we create here?
Oh, perpendicular. I mean,
Oh,
parallel.
Oh.
So that's why you wanted to try to be as accurate as you could, because if you didn't do it, it was going to end up not parallel. But we should have ended up with parallel lines. And since this was an enlargement, did we get closer to that point, or did we get farther away? We got farther away. So farther away from O. So make those little notes there. And I'm going to have you guys try the next one. It's a reduction. So do you think it's going to be getting farther away or closer to that original point? It's going to be getting closer. So try that one. What's my scale factor here? 1/2. So you're going to be taking half the length, and these should be the same. So you want to start the same way. You want to extend out your OA and OB. And then I'm gonna hide that one so you can't cheat.
I never cheat. Huh? What are we doing?
Did I?
I don't even know.
You're like a 30.
Okay, so we're just gonna make
What is she?
Oh wait, it's a dilation.
Oh my
this is yeah, a dilation. So you should have ended up with A prime at how many centimeters did you measure?
1.
1 centimeter. Do we still have parallel lines here?
Yes.
Yes. So we have parallel lines. And where did we go? Did we go farther away or closer to that point of dilation? We came closer to O. So notice when it's on the line, it will stay on the line. If it's off, it's either going to extend out or get closer, depending on if it's a reduction or enlargement. And it will be a set of parallel lines. So that is our notes for today. You have 30 minutes to work on your homework, and I think you have plenty of time to do that. You picked it up when you walked in.
Yes.